now that we have those 3 points, what are these values going to do? What's this 4 going to do? Y by 4. What's that negative a half going to do? X by a negative 2, yes. So you can write that above here, y by 4 and x by a negative 2. And then fill out those points. Again, I'll give you a head start. Then connect the dots. Woo, that one goes way off. Yes?
Why is x multiplied by negative 2?
Inside of this 0.5, we could write that inside as a fraction negative 1/2. So, and then anything inside is the opposite. So if you take negative 1/2 and do a reciprocal, you get 2 over 1. And that's why x is by the negative 2. So sometimes if you have decimals, you're going to want to change them to fractions so that you can do the reciprocal. Now, another key thing that you're going to want to notice is this point right here, negative 2, 0, was sort of the starting point of our original graph. That's right here. I'll call it the starting point. That's going to be the starting point of our new graph. Because I've seen at times, people make mistakes and say, I think this is the starting point, so I'll draw it like this. But if you get the wrong starting point, then that's going to cause some issues. If you're lucky, when I make a mistake on this board, it just erases like that. And starting point would be here and go this way. That's not true. It doesn't automatically erase when I make mistakes. That would be nice. Can you imagine you'd have that special pen on a test? You're like, oh, you write it. Be bad for English. You write a whole essay and then all of a sudden your essay's gone. But so there's our starting point. The shape is the same. Again, another thing I want you to think about is in function notation, this is what we had. And we should be able to describe each of these things. This is a vertical stretch. This negative reflects it over the y-axis. And the 0.5 is a horizontal stretch. So just as our overall idea, we take our red graph. Has it been stretched vertically? Yes. Our new graph looks like it's been stretched vertically. Has there been a flip over the y-axis? Yes, because our blue graph is now going in the opposite direction. And has there been a horizontal stretch as well? Yes. Our new graph has been changed, and we can see that. And so just describing what needs to happen also will help you see what the final graph should look like. Again, domain and range. This time, just to save some time, I'm going to do one notation for one and the other notation for the other one. So you don't have to write them both. So if I use set notation for the red graph, we would say that x is bigger than or equal to negative 2 for our domain, and our range, y, is bigger than or equal to 0. If I use interval notation for our blue one, what's the smallest x value? There is none, so it starts at negative infinity. It includes all the x values until it gets to 4, and it includes 4. For the range, is there a smallest y value? Yes, at 0. And it goes up forever, so we'd write 0 to infinity. Now, I'm not sure how much of that column you used up. Maybe you went all the way to the bottom. If you did, I think there's some space above the question. If you don't think that's enough space on the page beside it, you have space underneath example 2. What I'd like you to write is example 3.5, because it happens between 3 and 4. And I'm just going to take this original question that we had, and part A, I want you to write an explicit equation for y equals f of x. That'll be part A. We'll do that together. Now, y equals f of x is the original red graph that you have there. Sometimes they will show you a picture like that and say, what is the equation of that red graph? What does f of x equal? So which of our parent functions is it? Square root, cubic, parabola, straight line, absolute value? It's going to be a square root graph. And what has happened to our original square root graph? Remember, our original square root graph looked like this. And it had 0, 0, 1, 1, and 4, 2. Can you see a relationship between the red graph and our original graph? It moved to the left, right? So how do we write that? Well, that would be inside the function. And 2 to the left we would write as x plus 2. And then part B, we're going to write an explicit equation for y equals, and what was the actual transformations done? For f negative 0.5 x. Now, in part A, we had the explicit equation for y equals f of x. So that means that another way that we could write the red one, because y is equal to f of x, is f of x is the square root of x plus 2. And now we want to write an equation using what we know about functions for y equals 4f of negative 0.5 x. And that was our blue graph above. So I'll switch to blue. Some key things about functions. If you have original function f of x, which we do in part A, there's our x, there's our x. That's a key thing to recognize. What's going to happen in part B is we are going to have a 4 outside of our function, and then we are going to replace the x with negative 0.5x. So we can basically start with our original function, which was the square root of x plus 2, but I'm not going to write my x, because where the x is, I have to replace it with negative 0.5x. That's the highlighted part. And there's a 4 in front, so there needs to be a 4 in front of my equation as well. And this would be the equation of our blue graph. The explicit equation. Again, explicit equation doesn't have any function notation within it. Questions you can do for this one? Are 7, 9, and 10. This is where we're going to stop for today.